Hello everyone, this is the promoter channel and I'm starting to take apart this engine. This is an engine made by Isuzu. The exact model and technical specifications will appear on the screen now. So this engine was taken out of this kind of vehicle. My subscriber from Moscow or the Moscow region has already contacted me about concrete pumps, concrete pump trucks, vehicles with concrete pumps. But apparently this is also from some kind of equipment. I see here there's no clutch, just a damper disc with rubber. Honestly, I still don't know what vehicle this is from. I'll clarify later. There will be a photo of this vehicle or equipment. So what's the reason for removal? The engine overheated. They removed the cylinder head right there on the vehicle. Apparently they sent it for resurfacing, put it back together, and the problem still didn't go away. That is, exhaust gases are getting into the cooling system. So we decided to remove the engine and send it to me for repair. What's my task? Well, as usual, to disassemble it, inspect for defects, and see if it's even repairable or not. I found out there are some nuances with this engine. For example, the cylinder head can only be resurfaced a few times because of the gear. The intermediate timing gear is between the camshaft and the crankshaft. Basically, it can be adjusted in any way, and if the head sits a little lower, it starts to pinch the gear. Also, for example, there's information that the crankshaft bearing saddles can be restored here if there's wear on the bearings for one block. Supposedly the block needs to be replaced. Well, in general, I don't have experience with these engines. I just asked around to see what information is out there. So here we can see. The engine is a 4-cylinder common rail engine. Well, it looks similar, let's say, to the Cummins engine I worked on, the 3.8. It's about the same, just a bit bigger. This engine weighs 500 kilograms, 513 kilograms. According to the transport company's documents, it's 513 kilograms. As you can see, it's dirty and unwashed, but I can't clean it right now. So I'll be taking it apart like this, and I'll also check if there's any oil in the engine or not. I'm starting to take it apart and removing this now. It's all up top here. Here's the turbo, and this is probably the EGR system installed. So the turbo, this EGR system here, I'm not sure in the front. Well, basically I'm unscrewing everything as I go. Like I said, I'm not familiar with this engine yet, so I'll be unscrewing everything that can be unscrewed. Alright, so that's the amount of work we have. Let's get started. Let's go. Let's go. Yeah, we can see how much carbon buildup there is here. There's dust, oil, everything mixed together. This is our intake manifold, and there's soot, grime, dust, carbon buildup, and oil. In general, even from this you can judge the condition of the engine. There's probably wear, complete wear of the cylinder piston group. Well, basically everything you can imagine. The turbine is leaking oil and so on. Continuation. So what do we see here? Overhead camshaft arrangement. Camshaft. Here we have an intermediate gear. Looks like the rocker arm is stuck. There's no play. Here we have the rocker arms. Also the rollers. Those are the valve bridges. The valves are adjusted without hydraulic lifters. Valve bridges, there are no shims, and there is no engine brake. So, what do we have here? I need to set the timing marks now and check them. Alright, I'll take care of that now. Unscrew the rocker arm. I think that's it here. The first mount, the first bracket, it's solid and used for both the camshaft and the rocker arm. That's how it seems. The rest are separate. And the last one is also solid. Here we have injectors with a solenoid valve wiring. I've already disconnected the connector here. We can see that a double wire comes to one contact and a single wire comes to the other contact. All the wires are different colors. Well, we won't mix them up. I'm also removing the wiring now. I'm unscrewing the injectors. This is our fuel return line. Looks like there's a drill passage here and it comes out here. We also have glow plugs here. You can see there's a bus bar going to them. Alright, I'll check the marks now. I'll figure out the marks. Then I'll unscrew the camshaft, rockers, injectors and remove the cylinder heads. The cylinder head, actually there's only one head here. The head is pretty interesting. You can see the thermostat housing is built right in. It's a non-removable part and the manifold is right here as well. The injectors there are also pretty interesting, without the usual nozzles, just tubes. The injectors have an unusual design. No nozzles, so the tube goes straight in, with a rubber seal here for sealing. Overall, it's interesting with some unique features too. So my task now is to remove the cylinder head. Then I'll lay the engine on its side and start removing the oil pan, taking out the pistons and the shafts. Basically, it's just a rubber coupling. Here we have splines going inside, and here there are just 4 pins. So, according to the marks, I turned the engine clockwise. Here I got a mark, there's a fixed mark on the cover and a movable mark on the pulley. I did that, well, I marked it, meaning I turned the pulley more and checked that there were no other marks. Here it is just one. When the first cylinder reaches this mark, it's at top dead center on the compression stroke. That means the fourth cylinder has valve overlap. The first cylinder top dead center, compression stroke, compression. We can see there are gaps here now, which means the camshaft right here on the gear. Well, basically there's a letter or a number, maybe an 8. And it should be lined up exactly like this, with the cylinder head, meaning this tooth, this mark, should be halfway covered by the head, just like this. Well, it's about the same as on a Gazelle 405, 406 or 409 engine. Those have two camshafts too. There are two camshafts there. The camshaft marks are aligned with the cylinder head, facing in different directions. I think that's basically it. I don't really need anything else. Here our mark on the crankshaft should line up, and the mark on the camshaft as well. So the valve timing lines up. Well, I think there will be some more marks under the flywheel, or rather under the cover. Most likely, well, I'll take it off and we'll see. The most important thing here is that I figured out how everything is supposed to go. Here I unscrewed the camshaft position sensor, and here we can see someone. Oh no, that sealant, I thought it was scratched on. Here basically we had a rubber plug installed. I removed it apparently to get access to this bolt. Well, actually everything is clear with the timing marks. I'm taking off the cylinder head. We can also see the camshaft bearings here. So, we see here on the bridge there's an adjustment screw, just like on a Volvo, for example. That is so that this, well, basically the guide, this bridge moves along the guide, and so that there is no misalignment. So that one valve doesn't open earlier and the other later. First this bridge is adjusted, and then the valves themselves are adjusted. That is the nap. What kind of nap? Continuation, the nap. It should be, this can be to be continued. Well, the filtering element, continuation, the filter, it should be continuation. I removed the rear cover, the flywheel housing. Here we see the gears, the timing gears, well, the timing gears and the intermediate one. This is continuation, the shaft, then the pump, this is our fuel pump. Well, all of this here is intermediate gearing, and the continuation follows, let's say, here it hits this one, and here there's a direct gear block 1, 2, 3, like the bright ones. 4 intermediate. Here there's a direct gear block 1, 2, 3, just like right on the gearbox. But it turns out this one is the biggest. This one is with the crankshaft. It works, and the smaller one is the fuel pump drive. And then there's an even smaller one. This is the intermediate one. It goes to the second intermediate gear, to the camshaft. Here in the head we have another intermediate gear, and only after that comes the camshaft. Well, basically I don't need to set any more marks here, because our fuel pump is common rail. Here, obviously all this works without marks. The main thing is to set the mark on the pulley there. And I showed on the camshaft that everything is level with the head. These are our 2 marks. It's similar to a Volvo engine. There you also set the crankshaft in a certain position and the camshaft on top according to the mark. So I remove the gears. They are all installed arbitrarily. EU. I remove the gears, then I remove this front cover. It's also a solid aluminum one. Well, I also noticed a very interesting thing here. At least I haven't worked on engines like this before. So as we can see, there are no main bearing caps here. Basically the block just splits in half. Here's one part of the block, here's the joint, and here's the second part of the block. So I'm unscrewing all these bolts around here right now. You can see we have head bolts here, size 10 with a double hex. And here we have bolts that are actually holding it together. Basically, they apply force directly to the crankshaft, and as a result, this whole plate, which is about 7 or 8 centimeters thick, will come off completely. Then I'll be able to take out the crankshaft. It turns out there's one part of the block, the crankshaft, the second part of the block, and then on the sides there's one solid cover and the second solid cover. It's interesting. I'll say it again. I've never seen an engine like this before. I'm taking off all the gears, removing the oil pump and the high pressure fuel pump. Next, I unscrew the front cover, and then both of these mounts, lay the engine on its side and take out the pistons. I've already unscrewed one cover here to check the condition of the bearings and the crankshaft. I lay the engine on its side and take out pistons. We'll already be splitting the block and removing the crankshaft.
Так, значит, смотрим. Subtitles by Dimitorsa. The bearings from a working engine, let's say, have some small bits of metal shavings, some scoring somewhere, but nothing particularly critical. That's so. What can we see here on the bearings? Well, with the standard marking, standard, that's it. Well, I also want to say, for example, if you take the bolts, the head seems to be 14, right? But the bolt itself, I think, is 12, so it's pretty strong. And also the block is small, but the pistons are also powerful with a large diameter. So looking at the pistons, we see that there are 3 compression rings and 1 oil ring, and it's clear that the rings are worn out. There are practically no ridges on the oil ring, and we can see everything is covered in oil. And it's also clear that the compression rings are worn out. Well, the pistons themselves still seem to be in more or less good condition. Well, just a regular working piston. I also want to show that's all. The piston pin bushing is broken. And the condition of the bearings. Well, the condition is usually a bit worse in the connecting rod bearing. But basically there's nothing critical either. So I removed this upper cover. I'll show you the bearings now. The crankshaft basically is in pretty good condition. So if we're going to assemble it, the bearings can be installed as standard. Well, these are just some preliminary thoughts for now. Of course, everything will still need to be clean measured and inspected for defects. And what else do I want to say? Here, the crankshaft looks kind of disproportionate compared to the block. The block seems so small for such a crankshaft. Well, it's the same with the pistons. As I said before, they also seem disproportionate in size compared to the block. So basically the engine is disassembled. I'm taking out the crankshaft. Now I'll show the bearings as well, and then we'll sum up the results. So the bearing is in this condition, and I can say that it's basically still in working condition. I don't know how many miles this engine has, and now, according to updated information, this engine seems to be from an excavator or some kind of loader. But in any case, you probably already saw at the beginning of the video, there was a photo of some kind of equipment. I still don't know exactly which machine this engine is from. So the bearings are in quite working condition.
and the wear seems to be even. I was told that if the wear is only on one side, then there are already problems with the block and it can't be restored anymore. Well, theoretically, of course, it's possible. You'd have to grind this whole plate on a surface grinder, lower it, and then machine it. But again, what about the clearance in the timing gears? How will all that work? But the machinist said that these blocks can't be bored, and the condition of the bearings in the block is obviously a bit better. Well, and we can see what kind of oil it is. There's this blackness everywhere, deposits, carbon buildup, soot. There, as I showed, there's wear on the piston rings. So let's sum up what we're going to do. Well, first we need to replace the pistons. I don't know yet. I'll check how the sleeves are installed here. So we need to replace the sleeves. Most likely the block will go for machining work. Since the block will be at the machine shop, maybe the machinist will check it. The main bearing seats, if we have new sleeves, then most likely we'll have new ones as well. Pistons include the piston itself, the pin, the circlips, piston rings, and as I already mentioned, the piston pin bushing must be replaced. Next, regarding the crankshaft, I don't think there will be any issues. The crankshaft is basically in good condition, so we're keeping this crankshaft. The bearings will be standard, and there are no issues with the camshaft either, so we're keeping this camshaft as well. Well, the bearings will need to be replaced. As I showed earlier, we have these small bearings here, and as you can see, they're also standard size. Most likely there will be a new oil pump. I'll check its condition, clean it, inspect the housing and the gears, but that will be done later. Also, I think this coupling needs to be replaced. This is our flexible coupling. It goes onto the flywheel. It just goes onto these 4 guides and the splines fit in here. I don't know, maybe the gearbox or the hydraulic motor. Basically, it drives something there. Well, as we can see, it's already all swollen and cracked. As for the cylinder head, I looked at it and didn't see any repairs. The customer said the head was worked on, but all I saw was the gasket sitting on sealant. So if there was any repair, they just removed the head, cleaned something up a bit, and installed the gasket. Maybe even the old one that was installed, or maybe a new one. They just put it on sealant. Well, applying sealant under the cylinder head gasket is absolutely pointless. This kind of silicone sealant, it's completely useless. It doesn't have any effect at all. Well, and as for the cylinder head itself, I don't see that it was on a surface grinder or that anything was done here. So the head is just as it was. What year was it made? So I think that's all there is. Let me remind you, we removed the engine because exhaust gases were getting into the cooling system. What do I think we should do with the cylinder head? The first thing is to definitely replace the cups. Here, as we can see, there are injector cups. I don't know what they're made of: bronze, brass, copper, you can't really tell. Everything is dirty under them. There should be rubber seals there, so the first thing to do is replace these cups, install new seals and new cups. Next, the cylinder head needs to be machined on a surface grinder, and it's absolutely necessary to pressure test the head. That's to check the water jacket's sealing integrity. Well, of course, I'll also take it apart, check the condition of the valves, and inspect everything, including the valve guides. We'll get to that later. For now, everything seems standard. First, I need to clean all of this, and maybe we'll find some other defects. What should we do with the cylinder head? The cylinder head will go to the surface grinder. I'll definitely remove the gear now, but I'll also clean it up, blow it out with a brush, and then we can send it to the surface grinder. About the valves, this is the condition we see. There are carbon deposits, some shiny spots, and some areas are completely covered in carbon. Right now the exhaust valves are questionable. I'll try to rework the valve face, the sealing edge, and see what condition they're in. If they're still suitable for installation, then I'll install these valves with the treated bevel, but it's definitely necessary to replace the guide bushings for the intake valves. Basically, everything here is as usual, maybe a bit better. So my task now is to prepare the block for machining. Well, basically here I need to remove the bearing shell and take out the injectors by unscrewing the oil injectors. Here we have a valve installed, but I also need to wash it, clean it, and get it ready. So regarding the machining work, there's a nuance with this engine. I don't have experience working with these engines, but I found some information on the internet. And the machinist also got some information. So first of all, the cylinder head can be resurfaced here, and you can take off about 0.2 of a millimeter. By the way, I already have the head prepared. I washed it, removed the valve keepers, cleaned it, and now I'm getting it ready for lapping. Of course, there are some defects here, some pitting, and in some places there are marks left by the gasket. Here's the problem: you can only shave about 0.2 millimeters off this head, because right here we have an intermediate gear, and if the head sits lower, that is this gear, it sits right up against the camshaft, or rather against the second intermediate gear, and basically they start to get worn out. That's why, I don't know, I'll think about it some more. Well, as an option, if this cylinder head hasn't been resurfaced yet, and I think that's the case because there are still marks from the factory milling, then about 0.2 millimeters. We have enough margin to machine it. So I immediately put the block into the washer. It's already heated to about 60 or 70 degrees. I don't use diesel fuel for washing anymore. Now I use a new product, Revosol, a concentrate for washers with a flip-top lid. Well, for jet type washers it's the same thing. Sometimes people ask in the comments what I use, what's in the washer, so I'm showing you. So this is our first. It didn't budge, and you could hear a dull thud, meaning it was transmitted through the whole block. Now in Dimatorzok's covers, you could see that this sleeve was barely removed. So, as you can see, it's all covered in soot here. Everything here is rusty. Basically, everything is caked up. I don't know. I'll check now to see where this rust is coming from. Maybe there's a crack in the block itself. But, as we can see, everything there is dirty too. Now I'm going to clean and wash everything and take a look. So these 3 sleeves came out pretty easily actually. Maybe even if I had braced it from that side with a piece of wood or something, hit it, the sleeves probably would have come out. Now I need to figure out why this sleeve is in such a condition. If we look inside the sleeve, there are also corrosion pits here. And I also noticed on the cylinder head that on the first cylinder, as we can see, the first cylinder is also all covered in this kind of corrosion. So it turns out that coolant was getting into the first cylinder. And as we can see from the sleeve, not everything is in order either. I would have done it Dimatorzok so that we wouldn't have to throw out the block now if, for example, there's a crack in it. Well, that's just a thought again. I'm cleaning everything now. I'll take a look and then it'll be clear. So, and also we need to send it for machining with the cover, because here the cover, well, actually the head sits on part of the cover. If we, for example, remove 1/10 from the block but don't remove it from the cover, then we'll end up with a misalignment. That's it. Also put it in the washer. Now I'll wash it and also bolt it onto the standard bolts. And then the engine will be assembled. The 2 parts of the block and the cover. All of this needs to be taken to the machinists. That is there should be subtitles. And on the Dimatorzok cylinder we can see this kind of corrosion. I cleaned everything here. I didn't see any cracks. But as far as I could see visually, I checked everything. Well, in general there are no visible cracks. But to know for sure you need to send the block for pressure testing. I don't even know where they do that. Basically, I don't know, there are still a lot of questions about this engine. So, what do I think? I think all of this happened because of the cylinder head. Meaning the cylinder head started leaking antifreeze. Well, probably Dimatorzok, it's not antifreeze here. It's the engine most likely that was running on water. And probably even on water from a lake or a swamp. I don't know. Anyway, there's this layer of residue everywhere here. I was cleaning it out here, cleaning it out. I don't know. You can still see in the corners over there that there are a few millimeters of this cooling residue left. This lime scale or whatever it is. Plus, the cooling system here is such that everywhere there are these little holes. They're literally about 4 or 5 millimeters. Here are some slanted holes. Here, for example, in the bridges 2, 1, 2, 3, 4, 1, 2, 3, 4. I cleaned all of this out. I drilled it all out. Almost all of these holes were clogged. So I drilled them, I blew them out and cleaned them. So I spent several hours cleaning this block. And just so you understand the condition here, here's the cooling system. Everything here is covered in sealant plus all these lime deposits or scale. I'm not even sure what it is. And I think that's what caused the engine to overheat. So, most likely, the coolant was leaking under the sleeve from the head, meaning from the cylinder. If there was a crack in the block itself, then water would be getting into the oil. Our oil was clean, but right in the cylinder itself, where the ignition happens, so to speak, that's where we had water. In general, we don't know yet what we're going to do with this block, so for now we're sending the block to the machinist. They'll take a look, do the measurements, and give their verdict. Well, here's my personal opinion. My personal opinion on what needs to be done here. Let's see. Just like we did with the Dawson engine DV15. In my opinion, well, there we had a liner pulled through and the seating area was damaged. There were deep dents, scratches and impacts. What did we do there? We bored out the seat in the block to a larger diameter, made a custom liner, pressed it in at the machine shop, and then machine the pressed-in liner to fit the piston size, and it seems like the engine is working. Everything is fine. There are no complaints. No, I think we'll need to do the same thing here because, for example, if we look at this spot, everything is perfect. We installed a new liner here. It heated up during operation, settled in tightly, the walls pressed in, and everything works. Here we already have pits. This is corrosion. These are pits, and when the liner heats up, it will deform a bit there. In this spot there's a void. Here it's pressed in. So overall, nothing good will come of this. These are just my thoughts for now. We'll see what the machinists say. Alright, so I'll wrap up this video on disassembling this engine here. Thanks everyone for watching. Good luck everyone and goodbye.